Welcome to the Software Process and Measurement Cast number 879. I'm Tom Kegley, your host. Process debt swamps platform teams. Over-abstraction slows teams by increasing complexity. Even if you're not a platform team, I would suggest that over-abstraction is a bad idea. Profitability, employment are all highly related to productivity. Mark Fussell is the CEO at Diagrid, a cutting-edge company that simplifies building and scaling cloud-native applications. As the co-founder of Dapr, Distributed Application Runtime, Mark plays a pivotal role in shaping the future of modern application development by empowering developers to build resilient, distributed systems with ease. With decades of experience in the software industry, Mark has been a driving force behind innovative solutions that bridge the gap between developers and complex infrastructure. Before we dive in, remember, Mastering Work Intake, the book by Tom Kegley, myself, and Jeremy Willits on work intake, sponsors the Software Process and Measurement Cast. Have you bought your copy? Go over to J. Ross Publishing, buy a copy, or go to Amazon and buy a copy. Mark Fussell, welcome to the Software Process and Measurement Cast.
It's fantastic to be here today, Tom. I'm excited to talk to your audience.
A lot of this topic is near and dear to my heart. Mark, let's actually start pretty basic, and let's define the word platform. I was having this conversation with a client on the East Coast yesterday afternoon, and I got confused, and I thought I understood. So help us with what is, when you use that term, how are you defining platform?
Wow. Okay. So, to me, everything is a platform that sits on top of another level of abstraction. So I would always define it as a platform that suits the level of abstraction that fits your needs. And that sounds very generalistic, but in many ways, I would say that an operating system is a platform because it provides a platform of set of services on top of the underlying hardware for like saving things on your file system and memory and things like that. And then, of course, you'd like to think that you talk about a software platform that sits on top of your operating system in order for you to build sort of the next level of complexity of your application. So there, I would say, you get platforms like, you would claim that Kubernetes, which allows you to run, multiple operating systems together, is a platform because it coordinates now a set of machines and itself a platform. And then on that, I would say that you then get let's say language frameworks as a platform. So you get Spring Boot and .NET and things like that. And then people build on that. So to me, a platform is a level of choice that gives you the abstraction you need to solve the problem at that level. And I think, of course, today there's very much the rise of platform engineering, which is where people put a platform together that composes of a set of services and let's just say runtimes that help application developers be successful, deliver business processes. So for me, a platform is a level of abstraction that hides the things that you don't want to care about and gives you the level of control that you need.
So something like Salesforce, would you consider Salesforce an application or a platform?
Oh, I would take it as very much. They would definitely claim it was a platform.
Of course they would.
Without doubt. And I think it's true because you can turn up to that platform that provides a level of abstraction over, a set of underlying services and stitch them together to build a business application that, of course, is tightly bound to Salesforce and their APIs, but no doubt it is a platform. I would also point out that all the major cloud services like AWS and Azure and GCP, they would also be platforms. Those sets of services you stick together. Some of them very general, like providing you a VM. Some of them very much more specific to that particular platform, such as providing you some sort of diagnostic service. But you put them together. But yes, I would claim that it's a platform because you can build a set of services. But of course, some people like to have a requirement of being platform independent. So, not to that particular platform.
You brought up the term platform engineering or platform engineer. How would you suggest that a platform or platform engineering was any different than, systems engineering or software engineering?
Yeah, well, I think the way I think about platform engineering and the rise of this particular scope is the fact that over the last, let's say, 15 years now, organizations have recognized that they have to support and run multiple services themselves. So if you go back 20 years' time, it was very much that organizations built software themselves for their own internal processes as a whole. Now they build a lot of their own services that they release externally, and also build internally as well. But they realize that they have to not reinvent, let's just say, common software processes where they have to do deployments and monitoring and security and upgrades. And the DevOps model kind of sort of tried to encourage this independent team to take responsibility for all of the operations processes, as well as the infrastructure, as well as building the application. But it became very siloed. So you had this DevOps team building their thing and this DevOps team building that thing. And it turns out there was a huge amount of duplication and figuring this out. So when a company gets to a scale where they have more than one useful application that they have to use, in steps the platform engineering team that's a cross-cutting layer that will provide, for example, a common database service or a common messaging service or a common, say, security or a telemetry service, as well as a common workflow deployment process about how you deploy, upgrade, and roll out and do the process around this, such that not every team's reinventing it all. And the actual application teams or the solution engineers can build the thing that makes a company money, which is called the business application, rather than spending time sort of building and managing infrastructure. That's the role of platform engineering.
So if they don't exist in an organization, or they don't exist until much later as an organization scales up, what's the downside?
Well, there is no downside if you're, a small organization and you've just got, one application and you're doing one thing. And even if you just got two ones and they're very different, there's no downside there either. It's just that when you hit that particular point where, you are, let's just say, reinventing processes across these things. So the place you found this and has done it for years and years and years are all the major financial banks. Like every bank you walk into in the world has a platform engineering team, and they've had it for 30 years. It's nothing new to them. It's been very, and in fact, they have multiple platform engineering teams. I've talked to many large banks and they have, yes, we have 30 applications on this platform and 50 applications on that platform and another one over here. So it's very common with them. What's happened now is that, with the rise of cloud native architectures deploying onto these distributed runtimes, and the need for building services as a whole, platform engineering has become much more prominent and needed in many more organizations. And so it's kind of scaled down to the sort of medium-sized companies as well.
It's needed because it's a hot mess at this point and it needs to get sorted out, or is it just needed because that's the natural evolution?
I think it's a little bit of both. It's certainly the natural evolution there where you start to refine your processes themselves and make sure that you are working consistently, especially with, say, deployment processes, how you're rolling out a set of applications you have and not having to reinvent those processes. So I do think it's a natural maturity that has happened anyway. But there's also needed because you have to have this scope where someone has to have the focus. And this is very much a CTO level decision. The CTO has to drive this change into his organization in order to make sure that he can be, let's just say, productive in his use of resources. Because you want to make sure your people are aligned on the same direction, on the same task. So it's also a CTO organizational change that has to be enforced as well from the top down, very much particularly in order to align across the whole organization as a whole. So it's a little bit of both.
So do you see this as a quality or an efficiency play?
Oh, both. Well, yes, because the quality play comes in because you have I mean, what's your goal here? Is not to have 3 different database systems or 3 different messaging systems and to test them all 3 different times in 3
come
different
on.
ways.
As an ex-tester, that's a lot of fun, right?
It's a lot of fun, yeah, if you want to do that. No, yeah. And also it's a lot about, but it's also about enforcing best practices because let's just take a very common example. Most systems today have to do some form of messaging between systems. And that messaging takes the form of a message broker. Common ones being things like Kafka or RabbitMQ or MQTT and these brokers. And at some point, and you need these messaging systems because I need to do some work over here and I need to tell other systems to do something else on behalf of me. So message brokers and sending that messaging is a very common thing to happen. And it's always a big case of like, well, which one do we pick and who tests it all and who builds it all? And how do we make sure that we're running the underlying infrastructure efficiently and making that correct choice such that the application teams who build on top of it all have the right tools for them to be successful. So that's, and you don't want to do that. You don't want to do it all on RabbitMQ and ending on Kafka or an MQTT and have 3 different variants of it all when you just have one that will serve the purpose from all the teams' perspective. But it's also a process thing as well, because you can make sure that everyone has sort of, in many ways, limited choices. It's a bit like saying, in some ways, we are only going to use Java and .NET as our languages, and here's our templates we're going to use, and we enforce some boundaries rather than a massive free-for-all. So enforcing that, I think, is also part of it.
Do you think that enforcement reduces overall process debt, or do you think that it's the combination of, adopting other strategies and, constraints?
Well, the thing that people run into when you start to get into platform engineering in particular is, quite often architectural choices and design as it evolves. So you get, a lot of people focus on sort of the deployment and the infrastructure and how do I roll out my applications. But then the other thing that you run into is that you make some choice early on, and then you've got to decide how do I change that architectural choice later. Well, we had a good example of this one with FICO, actually. We worked pretty closely with FICO, and they early on made a choice that they wanted to use Kafka as their message broker for sending messages between things, and then realized that they hit some scale limit, and then they had to switch their whole architecture and wanted to use Apache Pulsar, and what that meant. And so the challenge of having to rewrite code and make a new adoption is a thing that can pretty much slow teams down and how they evolve for that. And that's one of the things that we focused on a lot, was helping application teams not have to rip out all their code and change their code if the underlying infrastructure wants to change.
How do you do that?
Well, one thing that I work on is with a project called Dapr, or Distributed Application Runtime, which is a CNCF graduated project. And one of its goals is to provide common, consistent APIs up to application developers, particularly for platform engineering teams, so that they can efficiently build their application design without having to be dependent upon the underlying infrastructure itself. And it does this by not only providing APIs that developers can use, like a messaging pattern API or a communication API, but also the ability for them to swap out the underlying infrastructure to allow for this code evolution, which helps them adapt and change in their overall architecture process as they move through. So that's one of its goals of the project.
So is that, when you were using the example before, was that one of the strategies you used to help them move from, one messaging approach to another?
Correct. Yeah. So with FICO, they did exactly that. What had happened is that the application teams had baked all the code in for Kafka into their applications. It was going to be about many months of rework to move to their Apache Pulsar. And instead they said, well, rather than just now jump onto another dependency, let's build in this Dapr client library, which provides a common abstraction over both these different message brokers for an API called publish and subscribe, how you can send messages between a publisher of messages and someone who can receive messages. And that way, if we do have a future choice again, we can always switch it out again without changing huge numbers of applications that sit above them. So this sort of evolution of your code and natural tendency to help change with design choices was exactly what they did. Yes.
For FICO, was that an easy choice, or were there a lot of proponents on, hey, we want to go to Apache Pulse?
There was a lot of proponents. Yeah, there was certainly a lot of proponents.
So how did that sort out?
Well, I don't know. I wasn't in the all those conversations, but I mean, you do need, one of the things you need, I think, in any organization is you need strong ideals in some ways. Maybe ideals is not the right word, but you need people who can see the future problems they've encountered before. Let's say experience matters, put it that way.
Fair.
And the experience of knowing that future changes are going to come ahead, rather than the sort of like, let's just build it ourselves, or build it, it'll be okay now. We'll figure out that thing in the future. So I think that's one of those things that an architecture does. He makes sure that you look towards future problems and encounter these things, and make sure. So in their particular case, they had a very strong architect who said, look, we're going to run into this again, and it helps with us today. Let's try this out and convince enough people.
Having been not necessarily in that scenario before, but having ripped out things that sounded good many years before and putting something new in, that is always a good time. And trying to explain that to stakeholders, why you can't get anything else done while you rip something out and just do the same thing over again. That's career limiting.
Correct.
The idea, right, behind all of this, it sounds like not only do you need platform engineering, but it also sounds like you need almost a platform architect or someone who's playing that kind of a role.
Correct. Yes. One of the things I spent many, many years at Microsoft building many large services, and also working with many large organizations. And, the biggest challenge we saw there was just reinventing the wheel, and reinventing, or what we like to say is reinventing the software pattern. And there's a great deal of desire for, a lot of people to feel as if they can write all their code from scratch because they like the challenge and this is what they do. And just like in many ways now, you wouldn't think of writing in assembler language.
Excuse me?
Well, unless you want to. I mean, but we created the next level of abstraction, and of course, even today, let's just take another example. You wouldn't write a collection library in your favorite language. You wouldn't write a linked list library anymore, which you'd like to do. You just use the linked list library around these things, and people have got to use or adopt that. There's still this general little bit of resistance about common software just architecture patterns, and that's just because there's many of them on different variety of platforms. But I mean, a common one, for example, going back to the messaging one, is how does you send a message from A to B, and how you discover another service and send them all, and people like to write these things. So this is where we identified the fact that wouldn't it be nice if you just had a common library of these very, very common patterns for these distributed architectures that were evolving, because we moved from a world where you ran on a single machine that was very large with a single database in the back end and this sort of architecture of just scale up a big machine, to a world where we ran on many machines, because not only was they sort of cheaper to run on sort of little smaller machines, but also you could sort of scale out and have the resiliency and the redundancy and failure. And so this world of multi-machine running things on, which is what the cloud sort of represents, needed software patterns that helped with the cloud. And that's what we identified. And so why don't we give the architects this tool so that they can use, so that they can put together the building blocks, or, a bit like Lego at that level, just like you put together, a building at that level, rather than having to no, before we go first, let's kind of understand how we're going to create a steel girder, and let's get into steel manufacturing. It's you don't need to create the steel, you just need to use the steel.
Yeah, that would be, I'm going to make a car, so therefore I have to learn how to create steel, or aluminum, or rubber, or blah, or blah. Yeah,
yes.
I've been in this industry for a while. I do remember the days when you had to write your own stuff because it didn't exist, and then we've adopted any number of different patterns over time. If you were talking to, your 25-year-old self and, knowing what you know now about this kind of platform approach, what would you tell them?
Well, I would say, if you're a compelling and driven software architect, you've got to figure out how you're making the company money. Yes, and it sounds fairly obvious, but you got to get the balance between making the business value for the company and making sure you drive the business value along with things like quality and delivery and things like this, coupled with, of course, future-proofing architecture, because software is an evolution process. Software is by definition a bit like evolution around us. It changes over time, it evolves, and pieces of software die because they get to an evolutionary dead end, and other ones keep going. So the evolution of your code, the evolution of your software, along with the business money making side of things, is what you have to be attentive to both. And where you should possible is kind of certainly reuse and take advantage of other technologies. And I think open source plays a big part of this. I mean, this is where we play into the open source side of those things. I mean, open source now is literally critical to the entire industry of everything. So I think looking around at the world of open source and using some of that, coupled with putting together and using common patterns and procedures around this, will be really the place where you should make sure that you should focus on and take those building blocks together and build those things and focus on the business value as much as it is the architectural value.
How did you get involved with Dapr? How did that come about?
Well, what was happening was I spent many years building the platform inside. Very early on, I joined the Azure team at Microsoft, where we were actually given the task of effectively, what is the platform that we're going to build these very large scale services? And the hardest problem to solve there by far was building the services for databases. Databases are these, long running, think of them as they have all the state and data installed in them. And if you want to build a service that runs millions of databases and, you have a machine that fails and it's got, say, 100 databases running on it, how do you make sure that there's no data loss around all of these things? So this was the core hard problem. So anyway, I got involved with building these large-scale services at Microsoft. We built a platform there called Service Fabric, which provided a lot of this technology for how you consume and use services at scale. And that led me to working with many, many enterprises and just seeing them reinvent the pattern time and time again. And so what happened with Dapr is we saw this happening and we said to ourselves, well, why don't we kind of create a common set of software patterns that architects could use to help them in their business application development. And also it helps as well very much with cross-cutting concerns. And something your audience will be very familiar with is like you should not go into production without good telemetry. And you should not go into production without good security best practices. And you should not go into production without having resiliency built in to your application. And these are often afterthoughts that happen in the architecture design. And so those were the core principles, is by using these patterns, you get security out of the box, you get telemetry out of the box, you also get resiliency out of the box, and rather than having to build it all yourself. And so now you can stitch these things together and be far more productive about getting your business application to market than you would have done before.
Use the word productive. Having spent a long time in the measurement world, what do you mean by productive?
Well, what we did a number of different experiments where we said, okay, so why don't you build this application that you want to deploy with yourself and just pick whatever else are. And then why don't you also build this with the Dapr APIs and the Dapr building blocks, which provide things like communication between your services, the ability to get hold of a secret to talk to a database, and particularly it has an API for doing this coordination of work of other processes. Call process A, call process B, a bit like a state machine. We call it workflow. And in that, in fact, there were a couple of great organizations that did this. One was a German company called Zeiss we worked with, and they built it themselves, and then they used Dapr, and it showed consistently that again, using off-the-shelf building blocks with Dapr, that they can build these things 30 to 40% faster than they would by themselves. So there was just huge productivity gains, coupled with the fact that they didn't have to sort of reinvent the pattern again themselves. So the productivity gains came from getting their thing into production, having less code to maintain, faster production, and flexibility. Those are the things they gained. And so doing those experiments very early on in the project, 6 years ago, with some amazing organizations who helped us. And even now, we do a common survey each year, which we ask, how much do you think it saved time with Dapr? We get people indicating that they've about a 30 to 40% gain in terms of delivering their software to production.
So not only productivity in terms of it costs them less and it costs them less to maintain, but it sounds like faster to the market too.
It is, yes. Because, this is why, the whole concept of distributed architectures or Microsoft architectures came to market. There's a design pattern anyway. You'll see that businesses demand today that you ship faster, ship sooner. And if you look back in the good old days where, you take SQL Server, for example, and when I first joined Microsoft, I was on the SQL Server team, and we just spent, 2 years building SQL Server. I think it was 2002. and it was this giant binary that, we shipped, and we put it on a CD and all cheered as the CD went out the door. And of course, and then you thought, well, let's plan our next 2 years. Well, that world disappeared, 2 decades ago now. And now, agility and getting things out is really why you have to sort of split these applications apart a little bit, because you want to ship this thing a little faster than that thing. So, but it makes it more complex, unfortunately, because now you've got multiple things that you're shipping at the same time. It makes your process management harder. It makes your release cycles a little bit more challenging of testing around these things for certain. And so you need some help around all of this. And so identifying that productivity gain of being able to build these distributed applications with common design patterns that fits it in with your process deployments and your processes, is really the goal of this.
Do you think AI is going to change anything in this whole platform engineering world, or is it just an additional approach and complication?
I think there's going to be places, it's certainly going to change things at the application world, what's happening there. I see lots of cases today where language models are very useful in terms of kind of helping try to automate a few things in different places. So for example, we're working with a logistics company, and they've built an application where they have a language model that helps the logistics person know when all the orders should be shipped for that day, and he can just query his database with language model himself and say, what orders have not gone out today and how do they ship these things. And the AI tools will definitely help, I think, you already see them today in sort of the process flow where, developers, when they push a PR or, a code release, they use the language models to kind of give them a code review. And I think that's all great stuff. I really do. I think where you have to be a little bit careful is in the code generation itself, and, how much of that code gets generated and where did it come from. And there's unfortunately this sort of self-referential thing that's happening where as more code gets generated with the AI, it's more, let's just say, not great code. And then it learns from the not great code to give you more not great code. So, you have to be, I think there's a lot of danger of that that's going to come down the pipeline. And so I think the code generation side of it, you're going to be very careful with, because already we've seen like amazing security hacks that happen because of code that people have no idea what they put together. So there's very lot of useful things in the application level. I think in the platform level, like code reviews, but I think in the code generation, we just have to still be a little bit careful there that we don't undermine experience with just expecting that language models do the right thing.
A little bit. I think you're probably underselling that. It sounds like we should be a lot a bit careful. Mark, this has been fabulous. If you woke up tomorrow morning and somebody handed you a cup of coffee, cup of tea, cappuccino, whatever your caffeine of choice is, a magic wand, and gave you 2 wishes, that would impact how, platform teams work, what would those 2 wishes be and why?
2 magic wishes. One is for them to realize that I guess they're on a continual journey that will always be the fact that people should realize that they're on a continual journey of evolution and that the software that they're building will constantly change, and how do they help kind of be the people that will continue to kind of keep their software running and systems alive around these things. And I guess around that would be, how do they make sure that they use tools effectively to help them achieve their aims, and just have that kind of general knowledge. I think the other one is, well, to recognize that a lot of the open source world of those things depends upon a lot of really great maintainers and people who go out there in order for them, and they acknowledge that, and in many ways sort of kind of support those companies both with monetary funds or contribution funds and things like this, because I think that there's a great amount of open source out there that people depend upon, and giving it a great level of support. So I think those are 2 things that I would sort of wish for, as it were.
Super. How would people continue the conversation? How would they find out about you? How would they find out about Dapr, your company?
Yep, come to diagrid.io. That's diagrid.io. That's my company, and that's our site. We're the primary maintainers of Dapr, the open source project. Feel free to reach out to me as well over my X feed or Twitter feed and around that sort of thing. I'm on there at mfussell@x.com, so you can do it that way. But yeah, come visit us at diagrid.io and go to the Dapr.website as well at dapr.io. That's another great place for resources, but always happy to chat to people.
Okay, super. I'll have those in the show notes. Mark, at this point, I open up the platform for you to promote anything that you'd like. The platform is yours, sir.
Well, I mean, I would just love to say to all your listeners, it's been an amazing journey for myself over the many years, building and seeing all the transformation change of technology. And I continue to be excited by what's happening, both in the development of AI and applications. And, we're here as a company to help you be successful and build your scalable solutions running on different platforms. So, please reach out to us and on our contact site, and we can make you successful with your projects and make sure that you get the business value you need. And we're here to kind of be architecture and design guidance, as well as make sure that you deliver great value to your business. And so, yes, great. It'd be great to talk to anyone who wants to reach out.
Mark Fussell, it has been absolutely fabulous. Thank you for spending time with the Software Process and Measurement Cast listeners.
Thanks for having me.
Next, you control you. There's very little under your direct control in the workplace other than your mind and your behavior. If you don't take control of what you can, someone else will do it for you. The SPaMCAST 880 will post in 2 weeks. If you'd like to participate, let us know at spamcastinfo@gmail.com. We look forward to the conversation.